Okay, welcome back. As I mentioned before, we're going to move on a little bit, talk about some timers, counters, and some math instructions maybe. So let's get into that right now. I think what we're going to do is I've started back at the basics. So I have nothing loaded right now except for the base project that we started with. And I'm going to quickly add a couple of timers and show you a couple of things from there. Okay, so I'm finished downloading the new blocks. I've saved the project. I've created the on time and the off time again. I've started the timers with the input 0.0. This time I've created a new block called control. And control is sending, let's go to monitor that, sending the output of on time to my output Q 0.0. So the reason I did this is I want to show you what happens if I edit the block and then change it back to the original program. So let's go ahead and drop a contact in the middle of this rung and call this stop. So maybe that was an edit you had to do on the floor because there was something wrong with the machine. So we go ahead and we download that block. Say load. Now downloaded that block. It's some sort of change you had to make to get around an issue that you had with the machine. In this case, if I turn the stop switch on, my output turns off and will not execute as on time toggles on and off. Okay, now let's just assume this did not get saved to our backups. Okay, so now at the end of shift, electricians fixed the problem. They've come in here and they say, okay, I don't need this temporary contact anymore, so I'm going to go ahead and delete it. And I'm going to send this original rung back to the PLC. Okay, so we've sent the original rung back to the PLC. Everything compares. Okay, but I'm not going to save this. This theoretically is exactly the same as the project I saved earlier. What I'm going to do is just recall the original version of that project. So I'm going to go ahead and open my lab 1, save the changes in the current project. I'm going to say no. Let's just say that was a temporary change made on a different computer for the sake of argument. And I'm going to go here and try to go online. Now Siemens does a check. It says, wait a second, FC2 isn't the same. If I take a look at FC2, I just happen to know, because we just did it now, that this is the same rung that's in the PLC, or the program says it's not. Now, if I take a look at this icon, put my mouse over it, it says online and offline are different. Okay, fine. Let's right-click this, go down to Quick Compare. We're going to compare with online object. Now it's going to tell me it has to close this block in order to check it. So it's got to close it, does a quick check in the background, does a compare, comes back, and it shows me the comparison of the offline and the online block. Now if you take a look down here at the comparison result, it says online, offline, block contents are identical. So that can be a little bit confusing. And really what's happened here is the timestamps are different. That's the only difference. So Siemens takes a look at the timestamp, and does a quick compare and says, wait a sec, the timestamps are different. You might want to check these blocks out. You do a more detailed compare and take a look at your comparison results, and it will tell you that it is identical. The only way to fix that is to send that block down again. So say this was our backup. So I'm going to close this comparison result. So say this was our backup. So I'm going to highlight FC2. And I'm going to re-download that block. And now our block compares again. Even though we actually didn't have a block that was different, because the timestamps were different, Siemens reports it as a change. So I'm going to open FC1 again and monitor our timers again. So this is one way to monitor our timers. We can just take a look at the online copy of the program and we will get the time displayed above the timer in both cases. But let's say for an example we wanted to take a look at everything that was going on and didn't want to have to scroll back and forth or flip back and forth between blocks. What we can do is go to Watch and Force Tables. We're going to open this up. I want to add a new watch table. And let's just say we want to take a look at our on-time timer value, and we want to take a look at the elapsed time, which is ET. I want to take a look at my off timer, elapsed time. I want to take a look at my input start. I want to take a look at my input stop. And I want to take a look at my output on. Now I can go up here to this icon, which is our monitor icon, the glasses with a little arrow. Okay. And now I can watch that monitor occur. If I save my project at this point, that watch table, which is called watch table 1, will be saved as part of the project. I can rename that. I could call that Lab 1 watch table. Save. So now anytime I open that project, I will have that watch table already programmed in. So this is fairly powerful because you can save your watch tables and see what's going on with the PLC. Just log in, take a look at the watch table. You can know all your important inputs, outputs, timers, internal data, all represented here on one table. Now if you notice this column here, okay, if I mouse over it, it says shows the checkbox for selecting the tags to be modified. So one of the other things I can do on this screen is directly modify the values. So let's go ahead and try to modify the output Q0.0 and turn it on. Under this modify column, I can just go ahead and type in true, hit enter. Okay, and we get a little icon that comes up here. It says the selected address is not being modified on the CPUs because I've told it to be true, but I haven't modified it yet. So we're going to go ahead and modify all selected values once. So what happened is if this output was off, it modified it to on until the next scan of the PLC modified it back to false. And that could have been the next scan. Okay, so this isn't a very good way to show how to modify values. So I'll tell you what, let's put in our auto output, which is Q0.1. Okay, now this output is not being modified in the ladder logic. So if I go ahead and type in true here, okay, now it hasn't modified it yet because I haven't told it to. And I'm just going to take this one out. I'm going to go up here and select modify all selected. And now it's modified this output Q0.1 to be on. Now the only reason that's staying on in this case is because there's no rung logic in the PLC which actually turns that off. And you saw that with the Rockwell PLCs with internal tags that we were toggling on and off that weren't actually being used anywhere. We were just using those to as temporary bits. We toggled the bit on or toggled the bit off. So that's basically what we're doing here. So this only works if there's no ladder logic actually turning this off. Well, there are times where we want to actually force an output and keep it on. So how do we do that? Let's take a look. forcing this output on if we don't actually want it to turn off. Say I want it to turn on and I want to edit the program. I just want to force it on. I want to try something in the PLC or try something on the machine and force this output on because we think toggling is causing us a problem. So we go here to the force table, type in our output on. Okay, now it's a peripheral output, so it won't allow us to monitor this value. See, it says not possible to monitor peripheral outputs. Okay, which is fine because we'll just use our monitor table for that. So I want to force it to be a 1 or true. Okay, now it hasn't forced it yet because I haven't enabled the force. If I cursor up here to that red F with the arrow, put my mouse over it for a second, it says start or replace forcing of the visible addresses in the force table. Let's go ahead and press that. You get a, now because forcing outputs on a PLC is inherently risky, you have to be very careful what you're doing. So you get a message, caution, do you really want to go ahead and keep forcing? You say yes. Okay, wait for the force to turn on. Okay, you get this little icon here, it tells you the force is active. If I go back to my watch table, it will tell me the result of logic operation, true, false, toggling back and forth. But you'll also notice I have the little icon here, the F, with a little green icon beside it, showing that the output is still on. If I was to take a look at my control logic, back to monitoring, okay, you can see that the logic still tells you that that output is supposed to be turning on and off, but I have the little force icon here telling me there's a force icon, there's a force active. Okay, let's go back to our force table, and I'm going to go ahead and press the stop. Again, another message, stop forcing. Yes, and it removes that force. Go back to my watch table. You can see now it toggling back and forth. The force icon is gone. Go back to my control. My force icon is gone there as well. If I save this project, that force table is also saved. So I could use that anytime. Call up the project, go to the force table, open the force table, and whatever I have on this force table I could do again without having to remember what it was like before. So whatever's on this force table is ready to go. Now I can force just one particular line, Q0.2 example. Okay, now there's no name for this because we actually didn't type it in the symbol table. And I could do the same thing here, true or 1, let's just say 1. Okay, if I disable the first one, when I force, only the line that was checked off will force. So I can selectively force whatever output I want to turn on or off. Now, in this case, if I remove the force, okay, and let's just disable that here. So, okay, I've disabled the force. I've removed it. I've disabled it. Let's go to our watch table, and we're going to add in Q0.2 and take a look at it. And you notice it's gone back to false. So let's go back to a force table. Force. Forgot to force. Go to our watch table. You'll see it's forced on. Okay, but it's supposed to be off, but it's forced on. Back to our force table. I'm going to go ahead and remove the force. Okay, I'm just going to deselect it there for a second as well. Let's go back to our watch table. You'll notice it's gone back to its original value. So the force is just temporary. No matter whether this output is actually scanned in the PLC or not, it will go back to its original value. However, on the watch table, if I right click and say modify to 1, we'll turn on true. And it's now modified to true. If I deselect it, it's still true. because I've actually toggled that bit on. So there is a difference between toggling the bit and forcing the bit. The forcing the bit will allow it to go back to its original state. Toggling the bit actually toggles the bit until the next scan. The PLC either turns it on or off. It doesn't matter. In this case, 0.2 is not scanned in the PLC. It's going to remain in its last state. So that's something to keep an eye on, something to remember the way Siemens operates. Now I can remove these values so I don't accidentally modify them again. You'll also notice if you mouse over this icon, it says address is not permitted and cannot be modified because it's the elapsed timer value. Okay, so that time cannot be modified. Another way to take a look at what's happening in the timer, let's take a look at the data block directly. If I open up System Blocks under Program Resources, I'm going to find my two instance data blocks, DB1 and DB2 for the two timers. Double click on this. Okay. I will find my data block associated with that timer. It has the preset value, the elapsed time, status of the input, and the output of that block. I have my little icon up here, it says monitor. Click on that, and now I can see everything associated with that timer by monitoring its instance data block. Okay, I'm going to close this for a second. And I'm going to close my watch table, close my force table, just so I don't have so many windows open. Go back to timer. Actually, let's just go offline for a sec. Now timers, let's take a look for a second. I've highlighted the timer, and I'm going to press F1 to bring up the help feature. So because I've highlighted the timer, hit F1, it brings up TON, generate on delay, and shows you more about that timer. So S7 1200 CPU is what we're interested in. If we scroll down, something I showed you in class already, the table gives you the parameters, the declaration, the data type, the memory areas, that sort of thing. You get some waveforms how the timer operates. When the input turns high, the timer starts timing, the elapsed time climbs until it reaches the preset value, and then the output will turn on and shows you graphically here this is your preset time. If I scroll down a little bit further, it gives me an example. Now if I scroll down even further, Siemens gives you links that are associated with the timer. So it says here overview of the data types, memory area, basic information ladder, and again more memory area. So let's take a look at data types. Now this is all data types, right? Overview of all data types is just linked to timers. Now the nice thing, they give you a little pull down menu here. So let's just select timers, select time, and this is what I had up on the class overhead. Time value is assigned duration, T, pound, and then whatever format you type your time in, and its length is 32 bits, which is a double data word. I'm going to go ahead and stop there. Next video, we'll take a look at counters and maybe some math functionality. This got to be a lot longer than I thought it was going to be at this point, but 20 minutes I think is enough for this video. Talk to you again. Okay, bye-bye.